Okay, we're going to look at a couple of examples here with context. And this first one, everything is already all written out for you, but I'll just highlight a couple of key pieces of information. And so when we read the setup to this problem, we see that the context is about social media companies making money from their advertising. And it says the following two tables show the relationship between average revenue, user session time, and percent personalization of the content. And we have a couple of tables here. Function F takes as an input the session time per user in minutes and outputs the average revenue generated from that user from advertising. And function G is taking as input the percent personalization of content presented and is outputting session time per user. And so the first question is asking, does F at G at 25 have a real world meaning in this context? And if so, determine what that meaning is and what the value of F at G at 25 is. And so if I just go to function G and look at what is G at 25, I see G at 25 is 30, and then that means that I'm really looking for what is F at 30, because if G of 25 is 30, then I'm looking for what is F at 30, and F at 30 is equal to 0.75. But does it make sense? Just because we have the numbers there, it doesn't necessarily make sense. So we have to look and see. We're looking at this function F. F has as an input session time per user. So this only makes sense if G at 25 is representing session time per user. And is that true? Is the output of the G function session time per user? And yes, it is. So we know that that makes sense. And so F at G at 25 is equal to 0.75, meaning that when 25% of the content presented to users is personalized, the average revenue generated per user from advertising is 75 cents or $0.75. So now let's look at the other way around. The next question says, does the expression G at F at 10 have a real world meaning? And so let's look at what inputs and outputs are represented. F at 10 is the output of the F function when the input is 10. The output of the F function is average revenue generated. Now G, what's the input needed for G? The input needed for G is percent personalization. The output of F is average revenue generated. So there's no way that I can take this output and put it in to that input. It doesn't make any sense in the context. Even if I could get numbers that worked, it makes no sense in the real world context. Okay, the next one is consider the equation F at G of X equaling $1. So I'm looking for now, when is the output of the F function equal to $1? What input causes that? So I look here in this column, the output of the F function. I find where it's $1. I see that happens when the session time per user is 80. So in other words, F at 80 is equal to $1. So now I need to find out, well, what would cause session time per user to be 80 minutes? So I need to come over to the G function and find out what causes the output there to be 80. And the cause of 80 minutes per user per session time is when the percent personalization is 40%. And so when G has an input of 40, G's output is 80, causing F's input to be 80, causing F's output to be $1. And so we find out that when 40% of the content presented to users is personalized, the average revenue generated per user from advertising is $1. Or we could say it the other way around, since we knew the dollar first, we would say that when the average revenue generated per user from advertising is $1. That means that 40% of the content presented to the users is personalized. All right, so now let's look at the next problem. The next problem, number 11 here. The following graphs show two functions, f and g. Here we have function f, function and function g. Function g takes as its input number of cups of flour used and outputs dozens of cookies baked in dozens, or dozens of cookies sold, because we're going to assume that all cookies that are baked are sold. And function f takes as the input the dozen cookies sold and tells us the revenue earned. So you can kind of see where we're going to go here already. We're starting with cups of flour. We find out how many dozen cookies we can make. We take that dozen cookies and we turn it into revenue. Okay, so let's start answering the questions. Does f at g at 20 have a real world meaning? And if so, estimate its value and explain what that value represents. If not, explain your reasoning. So we start with f evaluated at g at 20. So 20 is my input into my g function. Come up here. It looks like when the input to the g function is 20, the output is 30. So we would say, let me switch to a pen actually. G at 20 is equal to 30. And then that, we need to look at the context here. This tells us when I have 20 cups of flour, I make about 30 dozen cookies. If I take 30 dozen cookies, I make a certain amount of money. And so yes, it does make sense in this context. And I see that f at g at 20 is the same thing as saying f at 30. And f at 30 is approximately equal to right here. So I'd say it's approximately equal to $190. So the meaning of this is when 20 cups of flour is used to make cookies, the revenue earned, from the sale of the cookies is approximately $190. Okay. So the next question is then, does the expression g of f at 20 make sense? And so we're going the other direction now. Like if I come over here and I start with f at 20, 20 is the input to the f function, giving me an output of 140. Now, can I put 140 into the g function? It doesn't show it on this table. Doesn't go out that far in the x in that horizontal direction. But I mean, we could extend the graph, but does it have any meaning? And so if we take f at 20, what is that output representing? 20 is the dozen cookies that I've made and sold, right? And that gives me an output of $140. Do I need dollars for the input of the g function? No, the input of the g function is cups of flour used. So no, this does not make sense. Because f at 20 represents dollars, and it represents revenue, right? In dollars. And the input for the G function has to be cups of flour. So there's no sense to be made here. Okay, so now let's look at this last question. It says, consider the equation f at g at x equals 80. So I'm looking here, when is the output of the f function equal to 80? So I come over here, the f function, the output to the f function equals 80. That's right about here. Output to the f function equals 80. Follow that over, and I find that the input then is 10 when the output is 80. So in other words, f at 10 is equal to 80. So looking f at g of x equals 80, I know f at 10 equals 80. So what I really want to find out is, when does g of x equal 10? Okay, so I come back up to this graph now. The output of the g function is 10 when the input is somewhere between 6 and 7. We look here, right? It could maybe say 6.5, 6.6. So I say that G, let me switch pens. G at 6.6 is approximately equal to 10. So X equals, approximately 6.6 from what I can tell on the graph. And so what does this mean? So remember, we started back here with the 80. So we would say, when the revenue earned from cookie sales is $80, we used approximately 6.6, not 66, but 6.6 cups of flour. All right.